So good evening, everyone. We are continuing with training now for data science, and I'm glad and excited to be back here on this call. And yeah, so let's move ahead. A brief recap of what we did the last time we met. We attempted some visualizations, and then we looked at some conditioners. We looked at the if statement, the while statement, and R, the between statement. We considered the switch statement as well, where we were able to switch from an object day, and we switched over the different days of the week with a corresponding result that will show whichever day gets matched. All right, so we went further to look at some special manipulations, some special operations in data manipulation. We considered in particular the t package, where we explored it in detail from the package window here in our studio. We went further to design functions, and yeah, we did all of that. So we considered, as part of the dplyr package, we looked at the Star Wars data, and using that, we were able to use the select function. We used the function to be able to create new columns in our table. So we did all of that, and then we went by looking at the filter. Here in this example, we're able to filter the Star Wars data where the heights are greater than 20 and the hair color equals brown and all of that. So this particular example in line 464 helps you to filter your data for further manipulation. So this is an example for the mutate, how you do your mutation. If you're not using the pipe, this particular pipe argument, if you're not using this pipe method, in this case, you need to impute the data as the first argument. Okay, yeah, so that's for that. And then you can also do the summarize the data. Base just summarizing the column, the mean of the column and all of that. So this is where we find ourselves. We're supposed to do a couple of more things before we straight into modeling. And this class, we're training ourselves to simple linear regression. And for that, we're going to be having a very thorough project tomorrow to explain a real life example in this case to show us the various iterative levels of the linear regression model. Okay, good. So we need to look, it's very important to look at string operation. Yes, in R, we want to look at string operation in R, and you need a library, particular library. I think you might need. Just a moment, please. I just want to bring some of these scripts on strings. Okay, so for this, just a moment, please. Yeah, for the string operation, we are looking at we are trying to use this string R library. So you may want to have the library installed if you don't have it already. And after doing that, you will have to load it into your R studio. Okay. So when you do that, these functions become available to you. Okay, so this line 488 is the structure. If you are substringing the particular string you are trying to substring, the beginning position, the end position. Let's look at an example. Let's consider some example in that. So here is an example. You're substringing word or a string hello world, and this is how you give the argument. Number one is the start string, and then 5 is the end string, meaning that I want to cut off from the first string to the fifth string. And if I run this, okay, the function is not known because I am yet to load the library. Let's see. Now that the library is loaded, let's go back and run my systems again. Okay, where is the source string again? Sorry, don't know why this is Sunday. Okay, so in particular, I'm looking for the source string. Is it below? Maybe I deleted. Okay, string sum. Okay, so the minutes. Okay, this is it. So if we run this now, it gives us hello. And what happens there is that the first string is page, and then the last, if it's 5, is O, giving us hello string. All right. So this is to find the position of word. So it's going to give us the position of where this word starts from. Okay, in this body of string. So if you run this, it's telling us that it starts from 7 and then ends at 11. 7, 8, 9, 10, 11 words, right? So you can read more about the string R from the package itself. If you go to the package itself, you can read more about that. I hope that makes sense. So you can do a couple of other things. You see that in your notes. When we are done with the class, we'll forward the notes to you. So today's class is very unique. We are looking at modeling, and we're going to watch a video right now to give us a quick snap into the world of modeling, how it is done, after which we will do a simple example. From that very simple example, we will now go back and explain and do a couple of small modeling tasks. Tomorrow is the main project, which we're going to walk through from the beginning to the end. All right, so let me share screen for the main YouTube video. I, I pray you hear the sound from your end. If you don't, I may have to send you the link so that you watch it within the time interval. Just a moment. Okay, please confirm if you can hear the video. Is the video audible? Is the video audible, please? You can drop a message or speak. Is it audible? No audio. It's obvious why it's like that. See background. Okay, now I will also go to my site and continue the recording. How many persons have been able to watch the video? This person is still not talking. Okay, so let's resume the recording and move ahead with uh, what we have. Okay, so I'm going to show something else right now. Audio is breaking. If audio is breaking, I'm not sure it's from my end. I'm not sure it's from my end. So please, is it the same with every other person? Is my audio breaking? Okay, so it is. How is that? Okay, what do we do now? Um, is it still breaking? Maybe I should use the normal audio of the system and disconnect from this airport. Just a moment. Okay, it's better now. Okay, please kindly keep giving me updates so that I will know if it's better or not. All right, so we are going to look at a simulation of linear regression. We're going to consider a simulation of a linear regression pretty quickly. Let's see this. All right, so I want to believe my screen is visible. So this is a typical table that you have access to this link later in your materials. Okay. So this is a simple table that has gender, salary, age, place, the weight of the individual, the company, academic degree. So you can already see that this is a sample data, and we don't need the person's name, so the name field is not here. It's not useful anyway. So once you perform a regression, okay, a couple of things you can do. This particular site is very good to test some statistical knowledge. So we want to perform a regression. So which of the fields do we want to choose as our dependent or independent variable? All right. Remember, your dependent is your y, okay, and then your independent variable is your x. All right. So we want um we want to compare academic degree to to salary, for example. So the dependent variable is your let's say salary for dependent variable, okay? And then the independent variable is your degree. Let's see, there will be a comparison in that. Let's see if that will compare very well. Oops, sorry. Okay. So we have the salary comparing with the academic degree, comparing, I think there's a mistake there, I didn't choose the right thing. Academic degree and salary, system to kind. Just a moment, please. Okay, academic degree, masters, I don't know where this thing starts. Let's see how many degrees do we have here. We have bachelor's. Okay, I think we should use another comparison here. Let's compare and salary. Let's compare age and salary. Age is the independent variable, and then salary is the dependent variable. How does that compare? You can do that simulation here. Okay, so this is the model developed here, and you see that this thing has not updated. Let me, yeah, I'm reloading the page now. Possibly it will come up better. Okay, let's do that now. Dependent variable is salary, and then independent variable is age. Let's see if older people will earn more salary. So there's a factor you call the R squared factor. Um, R squared factor. This is what determines the level of correlation with the independent variable. Okay, you also have other factors. You have the F, you have the P. In some cases, you even have the S factor. So yeah, so this is the model itself. I will explain more in this using the example later on in R. So this is the model. This is the constant. Okay, I'm expecting to see a plot. Okay, so there appears to be a positive relationship. Look at it. There appears to be a positive relationship. Higher persons are earning more. But that is not always the case, but you can see that the general relationship is sort of positive. Okay? Yeah. Find some time and walk around this particular online statistics calculator. I'll share the link with you in the description. We'll go back to art now and do the real one that we can relate with. Okay. Please confirm if you can hear me. I saw the message drop in the chat. Am I audible, please? All right. So let's go into the artifacts to examine the modeling example once again. Okay. I said we are using the mtcars data to run the modeling example. Okay. So the first thing you want to do is to load the data. Okay. Just a moment. Let me help you to help myself. Loaded already. Yeah, so you can do str, am I right? To mtcars. So this will just give you the summary of all the everything in the data. They are all numeric values, although some of them are factors. Yeah, some of them are factors, as you can see. Okay, so let's go into, and you can also do what you call a summary, but the summary will not work for all. For those values that are real values, summary might work, but not for all. So let's do summary here. Summary will just give you the descriptive statistics of the data. As you can see, it gives you the descriptive statistics of each of the data. The ones that are factors, the values will not make any sense. Okay, so that is that. So we want to have an idea of, before we start thinking of modeling, which, I mean, you cannot just pick any column and model it with any other corresponding column. You need to have an idea of how they relate. Okay,
And how you do that is just a simple scatter plot. Or if you are doing a general correlation test, you can also see how they correlate. But here we are doing a simple scatter plot. Let's see how of course, remember this is a simple linear regression, not even multiple. So yeah, we are modeling one axis to the other in a multi-dimensional level where you model, where you are trying to uh, model a particular uh, column or a particular variable. You might be needing more than one independent variable to model it. Okay, so in this case, you want to model for the MPG, but let's have a scatter plot to describe how the two of them relate. So this is a scatter plot plotting mtcar, the weight value of mtcars. We're plotting that against the mpg values, and as you can see, it is very obvious. It's a negative relationship. Remember, it is going this way from the top left to the bottom right. That's a negative relationship. If it were to be from here, bottom left to top right, then that's a positive relationship. So what we have here is a negative relationship. It means that the slope is expected to be negative. Yeah, but we don't know what the value of the intercept is, but we know that it will be around here. It will be more than 25. Because if you draw a line this way, it's definitely going to hit around here. But so we are trying to now use linear model to know what is that line of best fit that will best describe this relationship. Okay, so that is what we are doing here with this model. So if we run this line, now this is LM, is what is used to fit the model. And then you have the variable, the dependent variable here. And then this sign here, check this sign, is beside your number one on the keyboard, left of number one. Okay. And then you relate that with the weight, which is the dependent variable. And then there is a comma. Here you have the data. I'm sorry, this is the data. You are using mtcars. All right, so let's run the model. To run the model has been run. Let's highlight this model and enter it just to give us the result of the model. So this is the result it brings. Of course, you're expecting two things from the result: the coefficient. What is the coefficient? Sorry, the intercept, and then the coefficient of the weight. All right, which is the slope itself. And I told us that what this means is simple. What this means is that this is the equation. This line 562 is the equation, meaning that the dependent variable MPG is equal to, uh, this model is run again, and they give something slightly different, but it's still, of course, when you keep running it at different time without using a seed, there's something you call a seed. A seed is what you give at the beginning that ensure that if you run it many times, it will return almost the same value. So because it's a model, it's not stable, it will give something slightly different. But as you can see, the weight, of course, the coefficient is the same, but this thing has changed a little bit. All right, so you are seeing the intercept, so will be 37.28, 37 plus 285. Oops, 37285 minus 5.43. Okay, I'm sure you understand why we wrote it like this. This is the intercept. This minus 54344 is the slope. Okay, so you can use this. So I said, how do we display the summary? If you want to display the summary of the model so that more details can show, you use the word summary on your model. Okay, so you pay attention to this right hand side. This is the description of it. The more the stars, the more significant the particular variable is. In this case, the weight variable is very significant. Okay, and then the intercept also is very significant. For that reason, this is a good model. This is the best this model can perform maybe another modeling technique can give us something better, but this particular data and the fitted model has given us this much. How do you measure it? There's something called coefficient of determination, or R squared. All right. So this coefficient of determination measures the correlation between the variables. Okay. Yeah. So yes. So you have the R squared here to be equal to 0.75. You may want to say more like a 75%, confidence as far as this is concerned. That means for 75% of the time, if you have the value of the weight and you fit it into this equation, whatever value of MPG you get will almost be the same. You want us to try it? Let's try it. mtcars data. Let's see the mtcars data. This is the mtcars data. So we are doing weight and MPG, right? So let us take the one for Hornet 4 drive. Let's see how closely we're going to get our answer. So for Hornet 4, if we put let's write the equation here. It will say MPG equals to 37.285, which is the model, minus 5.344. Remember, we're going to multiply this times, we're using 104 drive. This is the value of weight. We want to predict this 21.4. Let's see how near we can get. 3.215. So let's give this as 3.215, which is the essence of modeling. Meaning that if we get weight for 1,200 vehicles, I want to model what their MPG will be. How do we do that? So let's run this. What is the value of our MPG here? 20.10. So what is it? 104. We got 20.10, but the main result is 21.4. You could see that the difference is even more than 74%. I mean, the accuracy is more than 74%. Let's see. So 21.4, right? Our value was 20.10. 20.10 divided by 21.4. What is this? That is 93. So we got 94% accuracy. That is the benefit of modeling. We want to get a best fit line that helps us to model, that helps us to predict, as it were, the value of a dependent variable to its nearest value. So the real actual world value is 21.4, but we're able to predict using our model 20.1. We may want to try one more for these higher ones. This one, Toyota Corolla, the MPG is 33.9. Very good. What's that? Yeah, this is the weight side. Toyota Corolla, the MPG is 33.9, but this one is 1.835. 1.835. So let's change this to 1.835. 1.835. If we do that, every other thing remains the same. Let's see what is our MPG now predicted. Oops, this one is a little bit far, but let's see. 27.478 divided by 33. Let's see what it is. 33.9. 33.9. These are the extreme cases. What does it give us? It still gives us 81% accuracy. Okay, it still gives us 81% accuracy. The least you will get, Okay, from what our R squared gave us, the least you are going to get will not deviate below 74%, accuracy correlation. Oh, sorry, 75%. Our R squared is 75% or 0.75. Okay, so that's the benefit of this. All right, so I hope that made sense. Okay, I mistakenly typed 0.3. Oh, sorry about that. But I hope it makes sense now. Um, any more questions, please?
Ye- Yes, sir. When you were doing the value of the MTG, the one we said 21.5, I didn't see how we got the 20.4 that before the one was close to 21.4 that we had. I didn't see that place.
Okay. Um, let me go back to that and show you some.
Thank you.
Okay, so um, this particular one, please pay attention, sir. We ran this line of code, and when we ran this line of code, we had to type MPG so that we can get the value of MPG from this line of code. It gives us 20.10404. Okay. Remember, we were we were predicting for the MPG for this Hornet 4 drive. This one.
Oh, yes. Yeah.
Know the value of the weight is what we are using. So we want to predict for 21.4. We want to predict for the MPG, sorry. Okay, so when we use the model, remember our model is we got 37.285 as the thing for our model, the intercept for our model, and then we got minus 5.344 as the slope for our model. The idea is when you have the value of weight, we are trying to always predict for our MPG. That is why we developed the model in the first place. So when I plug in the value of 3.215 as the value of our weight, we ran the code, our MPG gave us this. Now we are trying to compare our predicted value to our real value. What is the deviation? I did this. What is the proportion of our predicted value to our real value? It gives us
0.9.
93, yeah, 0.93 or 93.9%. Okay, so our model was able to perform more than 90% accuracy. Okay,
Okay.
the result is us. So we went further to test for another one down there, Toyota something, Corolla or something. We plugged in again the value of our this thing. When we plugged it in, it was able to give us value of MPG as 27.47. And we'll do that again against the real value. This
Real
time
value.
around, the accuracy dropped a little. The accuracy dropped to around 81%. Okay, so the idea of a model of modeling is very simple. Now, in this case, we are good that we have this much amount of values of this data. What if you get to a situation whereby you have to predict MPG and all you have is the value of weight? And this is the beautiful thing about model. It's going to give you the approximate value of what the MPG will be, because a modeling line has been drawn over the data you have to give us a slight idea. So any deviation you are going to be having will not be too far from the model.
The model. Okay.
But in case you went and fit a model to a data that is very, very scattered, even your square will tell you that this model is not too accurate too. In our case now, in fact, we are even using an arrow square of 73%, 0.75. Sorry, 75%, 0.075. Normally, we should be aiming towards 90% R squared. In that case, that would be very fitting a model. As you do some studies personally on your own, you realize that in some cases, you are not supposed to even overfit a model because that may not be a representation of a real life scenario. So let's go with this. This is fine. Fair enough. Yeah. And we have done a good job. When we are doing the project like example, you are going to see how to implement this. That particular example is going to be for a multiple linear regression. You're going to see how to implement this in real life. When you have data, you want to model any particular aspect of the data using the other data that you have, model it. You won't have opportunity to test it. Okay, this particular field I've added is not adding any value to my model. Let me remove it. This one is not adding any value. Let me remove it until you get to the point whereby you see the ones that are the main ones adding value to your model. Those are the ones you retain. You get your final model, you can fine-tune it, and eventually you can use that to predict what you're trying to predict going forward. Okay, so that exactly is what we are going to do by the grace of God tomorrow. Yeah, any questions, please? Today's class is might be ending earlier. We will do more tomorrow. Tomorrow is going to be project based. So we are going to, please, for those who have attended until now, try and be here tomorrow so that you can see it yourself. I will also provide you with the data. You can do it after the class. You can repeat every step we take in tomorrow's class. It's going to be, I did not do this particular one from beginning. I only explained it to the last class. So you guys will have to see us work on it line by line till the end. Is that okay? Are we okay?
Okay. Cool by us.
Okay, thank you thank you everyone for joining. I think if there are no more questions, we will bring the class to an end here for today. Tomorrow we will look into the project. We will be taking only one project for this particular cohort. Hopefully you can take that up and build on that later on. I'll be here for questions in the chat, of course. If you have anything while trying whatever we have learned, you have anything you don't understand, put the message in the chat. I will respond to you as soon as I see it. Thank you, everyone, and God bless you.